In this example, we have nitrogen gas and oxygen gas reacting to give nitrogen monoxide. However, we are not given any sort of partial pressures in equilibrium. Hence, we have to take a different approach. Based on the question, we are given an equilibrium constant Kp, and it's equal to 0.88. In order to check whether our reaction moves to the right side, we need to calculate the reaction coefficient or quotient, Q. For this, we first have to set up our ice table and note down our initial given information. So to start off, let's rewrite our equation. So we have N2 reacting with O2 to give nitrogen monoxide, so NO. Next, our ice table setup would have partial pressures, so we'll have PI, PC, and PE. Now initially we have 0.500 bar pressure for both the nitrogen and oxygen, so we're going to have 0.500 and 0.500 initially, but then we do not know anything about the product initially, so it's going to be 0 in terms of partial pressure. So now that we have our initial conditions, we can figure out our coefficient quotient. So we have Q equal to partial pressure of NO squared over partial pressure of N2 and partial pressure of O2. Now, since we know that initially we don't have any nitrogen monoxide, we're going to have 0 squared at the numerator side, and for denominator, we're going to have 0.500 times 0.500. We end up with a Q value of 0. Now if we compare this to our Kp, we will see that Kp is greater than Q because Kp has a value of 0.88 and Q is equal to 0. Since Kp is greater than Q, we can say that the reaction moves to the right. Now, there's one quick way to remember this or figure out which direction the reaction is going to go, and that way would be to set K and Q in alphabetical order, just like here that we've done here. So we have Kp on the left side, so we put them first, and then we put our Q, and then we put our greater than or less than sign. So what we do next is that we turn this into an arrow. Whichever direction the arrow points is the direction the reaction is going to go to. So for this one, our reaction moves to the right. Now that we know that our reaction moves to the right, we can continue with our ice tables. So just like before, we're going to set variables. So for the change, for nitrogen, we're going to have negative x. For oxygen, again, we'll have negative x. And for nitrogen monoxide, we are going to have positive 2x. Equilibrium is going to be the sum of the initial and change conditions. So we're going to end up with 0.500 minus x for nitrogen. The same would be for oxygen. And for nitrogen monoxide, we will have just 2x because 0 plus 2x is 2x. Now we know that Kp is equal to 0.088, but we do not know what x is. So we can use this value of Kp to figure out what our x values are. So let us use the equation for Kp to figure out the value of x. Now, we know that Kp is equal to, using the same formula as before, we're going to have P of NO, or the partial pressure of nitrogen monoxide, because that is our product, and divided by P of N2 times P of O2. Next we just sub in the value of Kp, which is 0.88, so we have 0.088, so 0.088 equal to, we plug in our variables, so we have 2x over, since nitrogen and oxygen both have the same variables, we can just write them as a squared form, so we can write 0.500 minus x, because we know that if we have a times a, it's the same as a squared, so that is exactly what we're doing here. Now squaring both sides of the equation, we get square root of 0.088 is equal to 2x over 0.500 minus x. This is squared because we already have the coefficient 2 with nitrogen monoxide, so the squares got cancelled out with the square root, so we only ended up with 2x and 0.500 minus x. Now cross multiplying, we end up with 0.148 minus 0.297x, and that is going to be equal to 2x. Now solving for x, we end up with a value of 0.064. Now that we know the value of x, which is 0.064 bar, we can plug this value back into all of these variables for our partial pressures, and they will give us the answer. So we'll get the partial pressure of every single reactant and product in this reaction. Now that we have the value of x, let's plug it in. So for nitrogen, we are going to have our partial pressure equal to 0.500 minus 0.064 bar, which is equal to 0.436 bar. Similarly, we plug x back into this, and we end up with our partial pressure for oxygen being equal to 0.500 minus 0.064 bar, and that is equal to, once again, 0.436 bar. Next, we plug our x into the partial pressure of our product, which is nitrogen monoxide, and we end up with 2 times 0.064 bar, which is equal to 0.13 bar. Now that we have all our partial pressures, we are done. We have met the answers and can move on to the next question.